Hi everyone, welcome to the introduction session on field theory. Field theory, a course that forms the backbone of electrical and electronics engineering. I am Magesh Kumar, Assistant Professor, Department of EEE in the College of Engineering and Technology. In this video, we will talk about the core structure, core objective, and the application of this course. Let's begin. Let me start with a simple question. What makes your mobile phone communicate wirelessly? Why does a magnetic compass always point north? And how do we generate an electricity from motion? The answer of all these questions, the fields around us. That is, electric field, magnetic fields, and their dynamic interaction. In this course, you will learn to visualize the invisible. How charges behave, how fields propagate, and how they shape in a modern technology. This course is not just about an equation or a theorem what we are going to study. It's all about understanding the invisible forces that drive every devices today what we are using. So let's dive into the particular session. Once again, I welcome everyone and I'm excited to start this journey with you. Field theory is one of the most fundamental course in electrical engineering. It forms the basis for understanding and how electric and magnetic fields are work. So, to understand this, let's we go for the introduction course. The content of this session is what we cover for the entire session. The course prerequisite, course objective, and course outcomes. And the chapters what we are going to discuss, unit wise, syllabus, and the course learning resources, what are the learning resources are available, and then an introduction to field theory and its application. So this is the content what we are going to discuss for this session. Course prerequisite. Before we dive into the field theory, let's recall some prerequisite topics. You should be able to comfortable with the basics of physics, especially the material of physics, magnetism, vectors, and some scalars, the concepts beyond the calculus. This will help you to understand the subject easily. So some of the mathematical concept and some of the physics-based concept and magnetism. So these will help you to understand the subject smooth. The course objective. Our course is designed with a 5 course objective. The first one, understand the basic concepts in electrostatics. The second objective, you can able to acquire or the gain the complete knowledge in electric field. And the third course objective, you can recognize the concept and the basics of magnetostatics. The fourth one, learn an electron dynamic fields and how it's behave and how it's going to designed for a particular application. And the fifth course objective, and know the properties and understand the electromagnetic wave propagation and concept and all. So these are the 5 major key objectives for the course field theory. So to understand the field theory concept, we will have a small example with the help of a sports, one of the interesting sports, the terminologies, what we are having in this particular course, we can understand the help of one of the sports. You can see in the particular session, with the help of the cricket match, with the help of any sports, we can take it into, and we can take it into real-time application. So to understand that, I'm going to relate that and all with you or one of the cricket or any takes a sports that going to relate to our course theory. Okay. Course outcome. So the course outcome, after a successful completing of this course, you will be able to and apply the vector calculus in electromagnetics. And you can able to analyze the electromagnetic concepts. What are the concepts we are having? Evaluating the magnetostatics, understand the plane wave propagation, and comparing the reflection and refraction of plane wave propagation. So electromagnetic waves. So these are the course outcome for this particular field theory course. So after a successful completion of this course, you will learn or you will get these are the outcomes you can take away from this course. The course chapters and syllabus. The course is structured into 5 different kind of units. Unit 1, Electrostatics 1. That is, we take this module 1. Unit 2, Electrostatics 2. And Unit 3, Magnetostatics. Unit 4, Electrodynamic fields. Unit 5, Electromagnetic wave. We will study these chapters in order to build the concepts progressively. So let's start our journey from this unit or from this module. We will understand what is field theory. So the syllabus, unit-wise chapters are field theory that includes for each module having different chapters, and it constrains a structured syllabus. So we can take the course plan to complete all these chapters as per your module or as per your syllabus. Unit wise, the course plan for the field theory is we can take it for unit 1. After completing of unit 1, I can go for unit 2 and unit 3, unit 4 and unit 5 frequently. This course supports a key engineering values. Those are, I can say, the problem solving, determination, application, and a lifelong learning. For all this, as a future engineers, I'm mastering these fields which enable you to tackling all the complex systems. So this is a lifelong learning course. The field theory is a lifelong learning course. Now coming to the books, textbook and reference books, these are the primary textbooks we will follow. I strongly recommend the starting with the Sadikyu, the Principle of Electromagnetics. That is the first textbook we can go for, the Matthew Sadikyu, a Principle of Electromagnetics. And supplementing the books by Hyatt, Wenger and the Karus. So these are the books I can refer for the references you can take. Of course, even besides this textbook, we should also refer some of your online contents like from NPTEL videos and YouTube lectures and PDFs. And that also going to share in your platform, the learning management system, the Google Classroom forum. Here's the few curated links that are highly beneficial to understand about this course. And what you must do while we are in this lecture series of field theory, you should be proactive, follow the classroom's updates and referring the books use your laptop or mobile wisely, and whenever you want to take for any important topics, you can take a screenshots and participate the classroom activities like Google Classroom and our LMS Portal Classroom. So you have to participate and you have to be proactive for this field theory course. Your performance will be evaluated through some assessment methods. So here we will have assignments, we will have some quiz, we will have some of your short answers, internal bites, online assessment, and other deadlines of submission of your performance will be evaluated through assignments, quizzes, short answers, internal test, and online assessments that makes the course assessment for your internal purpose and stay enough a field theory. So we should know what is field theory first before we go into the course in a depth. The field theory is a study of how the electric field and magnetic field behave. It is essential for understanding how the electrical and electronic devices are operates. For example, let me take for communication systems and power machines and all. So to understand that, we should know the electromagnetic field theory. So the electromagnetic theory is a discipline concerned with the study of charges at rest and in motion. So I can say the study of electric charge we are going to understand by this particular course. The electromagnetic principles are fundamental to study the electrical engineering and from basic physics. The electromagnetic theory is also indispensable to the understanding, analyze, and design of various electrical, electromechanical, and electronic systems. And where we can use this field theory, or what are the applications or concept beyond the some of the areas we can say? I can say the communication system, power system areas like RF communication, microwave engineering, antennas, electrical machines, satellite communication, atomic and nuclear research, radar technology, remote sensing, and EMI/EMC, that is electromagnetic interference and electromagnetic compatibility, and quantum electronics and VLSI, etc. So in electromagnetic theory, the quantities involved can be categorized the source quantities and field quantities. The source of electromagnetics is an electric charge. Okay, that we are going to make it in the form of a rest position or having some motion. However, an electromagnetic field may cause a redisturbances of charges that in turn changes the field, and hence the separation of cause and the effect is not always invisible. So already we told we are going to study the invisible force, a visible of invisible force. So the source of electromagnetic field. The electromagnetic field can originate from a natural source and also human-made source. So where this electromagnetic field can exist? Yes, of course, we have two sources. One is natural source, another one is a human-made source. The natural sources like a thunderstorm, a lightning effect, those are invisible to human eyes. The Earth magnetic field causes a compass needle to orient in a north-south direction and is used by the birds and fish for navigation. So the natural sources of electromagnetic fields are also available. Some of a human-made source of electromagnetic fields are the X-rays. The X-rays are employed to diagnose a broken limb after a sports accident in hospitals. The electricity that comes out every power socket has associated with the low frequency electromagnetic fields. So around us, we always having an invisible force. The force we called as electromagnetic force. So some of the important terms that related to your electric field theory. So if we have some of the fields, we know that the basic two fields are electric field and magnetic field. And the combination of electric field and magnetic field, we call it as electromagnetic field. So when we have an electric charge, the charge around the region or the space, the corresponding value of some physical function, then the region is called field. So the fields are electric field and magnetic fields. The electric field having two types, one is a positive electric charge and negative electric charge. Such charges produce a field around in it. We call it as an electric field. So that moving charge can have to produce the electric current. When coming to the another term, the magnetic field, if the field is produced in due to the magnetic effect, it is called as magnetic field. The current carrying conductors have produced a magnetic field and electric charge here in the way of a motion. The combination. So we know that the combination of electric field and the magnetic field, we call it as electromagnetic field. So I can say the electromagnetic is a branch of physics or electrical engineering. The electric and magnetic fields are related to each other. Such fields are called as electromagnetic field. The fields may be the time varying or the time independent. To quantify the fields, the three dimension, the representation can be made easy to use of vector analysis. Yes, of course, we are going to analyze with the help of the dimension based representation. To quantifying the fields, how it going to distribute it, how it going to find in a different places. So coming to the core concept, what is meant by electromagnetic field or field theory? We can say the electromagnetics is the study of interaction caused by the time varying charges and current. Here are some of the questions to think about as we go forward. What causes a field? Why does it behave a certain way? When does it changes? It's very simple. We can have the electromagnetic field theory in everywhere. So the electromagnetic field theory deals direct with the electric and magnetic field vectors, whereas the circuit theory feels the voltage and current. The voltage and current are integrated effects of electric and magnetic field respectively. The electromagnetic field's problems involve a three-space variable along with a time variable, hence, the solution tends to become a correspondingly complex. So the vector method is only applied to identify these electromagnetic concepts more conventionally expressed and best is comprehended. Since we can use the vector analysis in the study of electromagnetic field theory, we can have the result and the real economy of time and thoughts. So when the electric charges are distributed, in a different kind of an objects or different kind of electrical devices, that also going to make electric field and magnetic field around the devices. So let's now connect with what we have learned to the real world. Let me take some examples or application and we can understand what we are going to link with our real time. So let me take a smartphone. The using of electromagnetic waves to transmit a signal. So a smartphone is going to operate or communicate the signals by using electromagnetic waves. The antenna systems inside are designed using electromagnetic field theory. When we take the another example, the induction cookups, they heat metal pots using changes in the magnetic field. This is one of the direct application of electromagnetic field theory by using a Faraday's law. And the another one in the medical industry, the MRI scan, the magnetic resonance imaging. A medical imaging uses a strong magnetic field to look inside the human body. There also the electromagnetic theory at works. And now the recent technology and recent evolvement in the industry, electric vehicle. We can take the motor and the drive systems rely on only or depends on the electromagnetic field behavior for the torque generation and control. And of course, the wireless charging system, it happens through a mutual inductance concept. That also another gem from a field theory. So these are the things what we are frequently day by day we are learned from the real world. So the field theory is going to connect your real world also. Your real world also. So now coming to this summary of the session, today's session. As of now, to summarize the introduction part of field theory, we know the outline, that is the course prerequisite, the course objective, the learning outcome, the course chapters and course syllabus, and what are the learning resources we are having, textbook and online tools, and of course the some of the basic introduction of field theory we also discussed. So as of now, we are in the introduction part of field theory. So we are ready to begin a deep diving into the electrostatics in a next session. With this, thank for watching this session. Thank you for your participation in this session. An active participation that leads a deep understanding of field theory. So that's all about our introduction of field theory. In upcoming sessions, we will explore how the electric field and magnetic fields are behave and how the engineers like you use them to design for the modern system. If this excites you, stay curious and keep questioning what happening behind the scenes in every devices. Until next time, please stay grounded in the fundamentals and keep reaching for high voltage success. Thank you for watching. Happy learning.